Today we're talking about finding the mean. When you have a set of data that consists of multiple numbers and you want to find one number that kind of represents the entire set, you may want to use the mean. The mean of a data set is the sum of the data, all of them added together, divided by the number of data values. Sometimes when we are finding the mean, we see that our data has an outlier. An outlier is a data value that is much greater or much less than the other values. An outlier can affect the mean. So the first thing we're going to do is see how we actually find the mean. So this table shows the number of text messages sent by a group of friends over the course of 1 week. And we want to figure out what is the mean number of messages sent. So when we're finding the mean, we're finding a type of average, like one number to represent about how many text messages this group of friends is sending to each other during the week, like how much per person. So Mark sent 120 messages, Laura sent 95, Stacy sent 101, Josh was tops there with sending 125. Kevin was at the bottom sending 82. Maria sent 108. And Manny sent 90. So the first thing I would want to do is add up all of the text messages sent by the friend group total. So I'm going to use my calculator to add these up. So I'm adding up 120, 95, 101, 125, 82, 108, and 90. And I get a grand total of 721 total text messages sent. Now this number itself does not represent the mean. What I need to do is I need to take that total and I'm going to divide it by how many people were sending the messages. So I'm kind of finding an average per person. So I have 1, 2, 3, 4, 5, 6, 7 friends in this group sending the messages. So I'm going to be dividing by 7. So I'm going to do 721 on my calculator divided by 7. And I get 101. This number right here represents our mean. Now there are people in the group who sent more text messages than 103 and those who sent less, but this is kind of a central number to represent how many each person was sending. In this example, we have a double bar graph which shows the monthly rainfall amounts for 2 cities over a 6-month period from November to April. And they want us to compare the mean monthly rainfalls for each city. So let's start with city number 1, which is all of the bars in blue. So city number 1, starting in November, had a rainfall of 3.5 inches in the month, then 2.2, 1.9, 2.1, 2.5, and 3.4. And I can use my calculator and I can add up all these individual numbers and I get a grand total here of 15.6. So in 6 months they got 15.6 inches of rain. Okay, but this is just my total. I have to divide it by 6 because remember this was for 6 months. So if I do 15.6 divided by 6, I get 2.6. So city 1 is getting about 2.6 inches of rain every month. Let's compare that to city number 2. So city 2's numbers were 1.7, 1.6, 2.2, 2.1, 2.7, and 1.7. Just from looking at my double bar graph here, I expect city 2 to have a lower mean because most of the bars are lower for city 2. So I add all these up and I get a grand total of 12. Remember, that's my total. This is over 6 months. So 12 divided by 6 gives me 2. So city number 2 gets about 2 inches of rain per month. So when I go to compare these two, an observation that I could make here is that City 1, on average, gets more rainfall, or more rain per month. So that's my little comparison of the two cities there. Okay, let's take a look at one more example. So this time the table shows the heights of several Shetland ponies, and they want us to use the data to create a dot plot. So that's the first thing we're going to do. So we have our number line here. We have a Shetland pony that was 40 inches tall. So I'm making a dot at 40. One that was 37, a 39, another 40, a 42, two 38s, a 37 again, a 28, and a 40. Now when I look at this data, it's very clear that this data has an outlier. This pony is way shorter than the other Shetland ponies. So this guy's an outlier, 28. They want us to find the mean with and without the outlier. So first let's do it with. So if I add all of those up, 40, 37, 39, 40, 42, 38, 38, 37, 28, and 40. If I add them all, the total sum that I'm going to get for all 10 of those numbers is 379. That's the total. But then I have to divide it by how many ponies there are. Well, in this case, I've got 10 ponies. So with the outlier in there, with pony who's 28 inches tall still being in there, we have a mean of about 37.9 inches. Now we're going to figure out the average without the outlier, which means this time when I add everything up, I am not going to add 28. That is not going to be included in my total. So if I add up the other 9 numbers without 28 in there, I get a grand total of 351. And this time when I go to divide, I'm only dividing by 9 because I'm not counting one of the ponies this time. So I'm dividing by 9, and without the outlier, my mean is 39 inches. So when I look at how the outlier is affecting this data, I see that 37.9 inches, that would be right about in here. This 37.9. Oops. Didn't do that very well. 37.9. And in this case, where 37.9 falls, there's not very many smaller than that, and there's quite a few larger. It's not a very great central number. But if I use the average, the mean, without that outlier, 39 right here is 39. I have a much more balanced ones lower than 39 and greater than 39. So when I talk about how the outlier affects the mean, I would say that the outlier definitely lowers the mean. Without the outlier, our mean is closer to the center of the data. And the whole point of the mean is to kind of get one number to represent the data, but we want it to be kind of a central number.